healthcare problems. So today, I'm going to go over the 3 common myths in building AI models for healthcare. So AI has been shown to have huge potential for many very challenging problems, including ones in healthcare. So for example, we've seen some very interesting work in the realm of applying AI for eye disease, for breast cancer, skin cancer, colon cancer. And the best part is that this technology seems to work in the hands of not just research scientists, but undergraduates, business owners, and even high school students. And in the recent years, we've seen a huge increase in the number of papers at the intersection of deep learning and healthcare. And given the adoption of deep learning based technologies in consumer products and these exciting studies, one would expect that we would have many AI enabled products in the healthcare space. However, the translation into product has been quite slow. And, why this gap between expectation and reality? So, the translation of AI into healthcare is obviously more challenging than it seems. And today I'm going to cover 3 common myths in building and translating AI models that might be contributing to this gap. There are clearly more than 3 blockers, but these are the ones that we've been able to identify as we're working in this space. So the first myth is more data is all you need for a better model. And what we found with our work is that it's not just about the quantity of data, but it's really about the quality of data. So I'm going to go over one example of this, but there are a ton of other examples of how data quality really impacts algorithm performance. So this particular example is rooted in our work in diabetic retinopathy. And so a few years ago, we set out to see if we could train a model to classify fundus photographs for this disease. This is a complication of diabetes that leads to vision loss. And the way that we screen for it is to take pictures of the back of the eye and then read the images to see if there are lesions that are consistent with either mild disease or really, really severe disease, which we call proliferative DR. So in this case, we started with 130,000 images, and we worked with 54 ophthalmologists to produce 880,000 labels, or ground truth diagnoses. We then took this data and trained a model using an existing CNN architecture called Inception and produced a fairly accurate model, one whose performance rivaled that of the general eye doctors that were part of this study.